All right, so today we're going to talk about using a technique called dimensional analysis to do easy unit conversions. And the nice thing about dimensional analysis is that for any unit that is multiplicative, for any unit that is just a nice clean ratio, you can use the exact same method to do it regardless of what kind of unit you're converting. So we'll try and do this really quickly and hopefully have it make a little bit of sense. I'm going to use a lesson here I use with one of my math classes. So a common unit conversion would be to go from centimeters to millimeters. And so we might have something like this pencil here, and we might have the question, how many millimeters long is this, if we know that it's 14 centimeters long? And that is obviously a pretty easy one, and you could probably do that in your head. And that's okay. It's good to be able to do math in your head. But let's also learn this technique of unit analysis or dimensional analysis. And the idea with that is, if we have 14 centimeters and we're not sure how many millimeters that is, we know that centimeters and millimeters have a relationship. There's a relationship between how many centimeters long something is and how many millimeters long it is. Whoops. And we can use that relationship to answer this question. So what we can say is that I know my object is 14 centimeters long, but I don't want to know how many centimeters long it is. I want to know how many millimeters long it is. And the trick to this is to use units exactly how we use numbers, which we know that if we take a number, if we took the number 6 and divide it by itself, it's going to equal 1. And that's true for any number. If we take 11 and divide it by itself, it equals 1. And if we take 200 and divide it by itself, it's equal to 1. If we take some unknown number, x, and divide it by itself, it's equal to 1. But that also works for units. A centimeter divided into centimeters is just 1. And a kilometer divided into a kilometer is just 1. So anything divided by itself equals 1. So since we have centimeters here, if we always get in the habit of multiplying by a fraction, and we put the unit we want to cancel, the unit we're not interested in this case centimeters, on the bottom of that fraction, centimeters will divide by itself to produce 1. And since anything multiplied by 1 is just itself, centimeters essentially goes away, and we can replace that with millimeters. So this mathematically means that we can make centimeters cancel away and we'll be left with millimeters. Now, what good does that do us? And in and of itself, it doesn't do us any good, because that will cancel the units mathematically, but won't give us the answer to our question. But the trick is, when we multiply by a fraction, we're multiplying by a ratio. And as long as that ratio is true, the answer will be true. So we can take a look here and we can say, well, when I multiply 14 centimeters by this ratio, wherein I want to stop talking about centimeters and instead I want to talk about millimeters, I need a true ratio. And it is true that there are 10 millimeters in 1 centimeter. The other thing I like about dimensional analysis is you can very easily say it out loud to yourself, and you can hear when things do or don't make sense. We know where the numbers go. So in general, we can do this. We can say the old number, or the original number, with the old unit, we're going to multiply it by a fraction, and we're going to put the old unit on the bottom of that fraction and the new unit on the top of that fraction. And again, this isn't to be like some kind of black box or some mystery box. The whole reason we're doing this is that when you divide something by itself, it cancels. And then the numbers can be any numbers that accurately represent a comparison between these two units. In other words, just a fact. Any fact can go there and it will work. Let's look at an example on the next page and and go there. So if you know a fact about centimeters and meters, you can do it. So how many kilometers have I traveled if I've walked 3,456 meters? And we know that a kilometer is 1,000 meters. Now again, you may instinctively know, well, I just divide it. That's fine, but let's follow our process. We know that we have gone 3,456 meters. That is our old number, our original number, a starting number, and that's our old unit. And we're going to multiply by a fraction. And on the bottom, we're going to put our old unit. So that's meters. And on the top, we put our new unit, which in this case is kilometers. And then here, we've got to put true numbers. And what I like about this is that you don't have to remember rules of when to multiply or when to divide or things like that. You can just say it aloud. If I get the numbers in the wrong place, if I accidentally said 1 kilometer, or sorry, that's the right place. If I accidentally put 1,000 here and 1 there, you could say it aloud. You could say I went 3,456 meters, and I know there's 1,000 kilometers in every meter. And as soon as you say that out loud, it doesn't make sense. So the nice thing is you know where the numbers go. We know that 1 kilometer is equal to 1,000 meters. And that's our fact. And with that being our fact, we can put that into our calculator, do that in our head, whatever it may be, and we know that we have gone 3.456 kilometers. Now, that is a fairly trivial example. The next one's pretty trivial too, but that's okay. Not a bad thing to do trivial work. How many seconds are there in a 20-minute quarter of a football game? And a reminder that 1 minute is 60 seconds. Now again, you may just know you need to multiply, but that's okay. Just to show our process here. 20 minutes. That's our old number. And our old unit. And we multiply by a fraction. At the bottom of our fraction, we put the old unit. And at the top of the fraction, we put our new unit, just like that. And we can just put any fact in here that'd be true. If you knew a different fact, you could put that in. But I think the fact most of us know is that 1 minute is 60 seconds. And now we can just do that math on our calculator. 2 times 6 is 12, times 10 is 120, times 10 again is 1,200. So 1,200 seconds. And again, the reason that works is anything divided by itself is 1. So minute divided by minutes is just 1. Seconds remains as our only unit. 20 times 60 divided by 1 is 1,200. How many inches in a 100-yard sprint? Well, that's easy. There's 100 yards we're going. But we don't want to talk about yards, so we're going to put that on the bottom of this fraction. And we do want to talk about inches. And then we can say 1 yard is equal to 36 inches. Yards will cancel with yards, so the only number that remains, or the only unit that remains rather, is inches. And to get the number, we would do 100 times 36 divided by 1. And 100 times 36 is 3,600. Divided by 1 doesn't change. 3,600. All right, and another example here. The dog here weighs 15 stone. And we know that we don't want to talk about stone. We want to talk about pounds. And we know that 1 stone is 14 pounds. Stone will cancel with stones, and that leaves us with pounds. 10 times 15 is 150. 4 times 15 is 60. So that should be 210. I hope that's correct. If I've made a mistake on this video, I'd be really embarrassed. But what I like about this is that we don't just have the ability to use it for simple questions like that. You can put these in a row. If I want to know how many seconds are in a year, I can do dimensional analysis, and I don't have to do it in multiple steps or keeping track. I can just start with the fact that we're going for 1 year. And I know I want to end with seconds, but we can just start by converting and say, okay, I don't want to talk about years. I do want to talk about seconds, but I don't know how many seconds are in a year. I don't have a fact for that. But you know what? I do know how many days are in a year. And I know there's 365 and a quarter days in a year, because every fourth year there's a leap year. That's 365.25 days in 1 year. And if you did this without the 0.25, that would be fine too. And now year would cancel with years, and if I did this, I'd know how many days. But I don't have to stop and write that down and then start again. I can just keep going. I can do another fraction and say, okay, now I don't want to talk about days. And again, I want to talk about seconds, but I don't know how many seconds are in a day. But I do know how many hours are in a day. I know that in every 1 day, there's 24 hours. So I can cancel those. And if I stopped now, I'd know how many hours are in that original year. But I don't want to stop there, because I don't want to talk about hours. I want to talk about seconds. Now again, I don't know how many seconds are in an hour, but I do know how many minutes are in an hour. So I can say there's 60 minutes in 1 hour. And again, hours cancels with hours. And if I stop now, I'd know how many minutes were in that original year. But I still am not done, because I didn't want minutes. I wanted seconds. And I know that 1 minute is made of 60 seconds. And there we get an entirely logical, really clean, really easy way to do that calculation. Now, I am not equipped to do this in my head, so I'll show you how to do the math on the calculator. We start with 1, and we multiply it by 365.25. That's 1 times that, and we have to divide by 1. Then we have to multiply by 24. Then we have to divide by 1. Then we have to multiply by 60. Then we have to divide by 1. Then we have to multiply by 60 again, and we have to divide by 1. And we get our answer. Oh, whoops. We get our answer that there are 31.6 million seconds in a year. So that's dimensional analysis and how we can use it to solve really simple little problems, but also we can use it to solve more complicated ones. I hope that's helpful.